I'm starting a new recording here for my integration methods, right? So for my integration methods, I'm starting a brand new recording. This is 5.5. And so we've already got a few of them. We already have a few methods that we know, right? The first one is you recognize the derivative. You know y prime, right? So what are we going to get? The integral of f prime of x dx is f of x plus c, right? So what I'm saying is I see the derivative. I know what I took the derivative of. That's my answer for my integral, right? So for example, the integral of 1 over 2 square roots of x dx, right? Right? I know, what did I take the integral of here? I'm sorry, the derivative of square root of x, right? Plus c is okay with everybody? Everybody understands plus c? Constant of integration, right? So think about it, square root of x plus 3. It's just the square root of x moved up, right? But think about the skier on the hill. The skis are still the same slope even though the hill is higher, right? So when I take the derivative, the constant goes away, right? But when I integrate, I got to bring it back, the possibility of it. So I know y prime. That includes a constant, a zero, et cetera, right? The next one is the power rule. And all of these methods, now I did these in 4.8, okay? I did these, I think I spent a class and a half on integration, right? Where I'm just saying find the antiderivative, right? And, but in all of the newer methods that we're going to do, it always will end up with one of these methods anyway. So we got to make sure we know about these. So for example, if I have the integral of x to the n dx, I know I get x to the n plus 1 over n plus 1 all plus c, right? Add 1 to the power, divide by the new power. So example, if I have the integral of 3x squared dx, what am I going to do to the power of 2? I'm going to add 1 and divide by the new power and then add my constant c. So it's 3x cubed over 3 plus c, or just better yet, x cubed plus c. Now what's nice about all of these problems is I'm going to know if I'm right by doing what? Take the derivative of my answer. Every problem on the quiz for chapter 5 that I ask you to integrate, every problem on the midterm that I ask you to integrate, every problem on the final where I ask you to integrate, you're going to do the derivative of to double check that you have it correct. The third one is not really a new one, but it's my sine cosine wheel. It's a wheel, right? So cosine negative sine, but when I'm integrating, I'm going backward. Right? When I'm going with the derivative, I'm going clockwise, integral going backward. So the integral of cosine of x dx is just sine of x plus c. tricks. We'll have lots of tricks. Divide and conquer, long division, multiply by 1, add 0. Yes. So we're talking about long division, multiply by 1, divide and conquer, add 0. Of course, when I multiply by 1, I don't change anything. When I add 0, I don't change anything. When I say divide and conquer, I mean take a single fraction and split it into multiple fractions. And long divide, when my numerator has the same or higher power of the denominator, I'm going to long divide. I'll do a couple of those. Yeah, you're looking for, so if you're stuck, and I kind of have this list as if you're stuck, you don't know what to do, you look at the next thing on my list and you try that. And what's going to happen as we go further, you'll see everything keeps failing. And so we have to come up with, we learn a new method and then learn another new method and another new method.
Can you go over divide and conquer and also?
Yes. Yes, I don't know if I'm ready to do an add 0 yet, but it shows up a little bit later. Go ahead.
Is this a hierarchical order you want us to start trying from?
Exactly. Start trying from 1, keep going. Obviously, you're not going to do 3 if it's not a sine or a cosine, right? But just an idea of trying to put things together. So divide and conquer would be like x squared plus 1 over x squared. Oh, no, that's stupid. X squared plus 2 over x squared plus 1. Now this one you can see is also a candidate for long divide, right? So this one's a candidate for long divide. Whenever my numerator has a higher or equal power of the denominator, and they're polynomials, I'm going to long divide, right? But this one I'll do as divide and conquer. I see that I have x squared plus 1 upstairs, right? And I'm going to cut this into 2 pieces. X squared plus 1 over itself plus 1 over x squared plus 1, right? You can see me splitting in 1 fraction into 2 fractions. But the first is only 1, right? The first piece is 1, and you can see that I would get that from long division anyway. Now remember what this integral is. What is it? What did we just spend the whole first part of the class doing? Yeah, adding areas. So it's a sum, right? Sum of the rectangles, right? Sum of the area of the rectangles. So I can split this sum up. And now I'm ready. Both of these, I'm back to step 1. Do you recognize them? And the answer is yes. The first integral is what? X. Second integral is arctan of x. Claire, I can't think of a add 0 right offhand, but I will. I just haven't done these in 3 semesters, so I don't even know if I like that part in my checklist. Yeah, and number 4, I don't even know if I like add 0. But that's okay, leave it there for now, because I think it will show up, and then I'll remember. Okay, ready? Here we go. So those we kind of all did already in 4.8, right? So here we go. We're starting with a brand new method. What we're talking about now is all of a sudden the chain rule is going to start showing up, okay? So this is U subs level 1. I think there's 4 or 5 levels. U subs level 1. So what I'm going to do is I'm going to notice that I have a function and its derivative in my integral. I'm going to notice that I see f of x and f prime of x dx and nothing else. So what we're going to do is we're going to turn this into an integral of u. By doing what? Let u be f of x and du equal f prime of x dx. So I'm going to u sub. I'm going to let the function be u, my brand new function, right? And let du be the derivative of that function, right? And once I get here, look what happens. What do I get? Do you see that I'm back to level 2, power rule? This is u to the 1, so what does it become? It becomes u squared over 2, right? So it becomes the function squared over 2. All right, we ready? E to the 2x dx. I still remember my college professor saying, it was a night class. He said, well, since this is night school, you all must be adults. So I don't know if you see the sex with dx there. I'm going to get you in trouble. Anyway, this is e to the x times e to the x. Do you agree? Agreed? When I'm multiplying like bases, what do I do to my exponents? Add them, right? So x plus x is 2x. Do you see a function and its derivative? So u is going to be e to the x. What's du? Everything else. So now look at what I have. I have the integral of u du. So what do I get? U squared over 2 plus c, but u is e to the x, right? So I get e to the x quantity squared over 2 plus c. And what happens when I'm multiplying, when I'm raising an exponent to an exponent, I multiply. So I get e to the 2x over 2 plus c. And there it is. Remember what I said about these integrals. You can check yourself by taking the derivative. I'm gonna forget. I gotta take attendance real quick. You can check yourself by taking the derivative. See who's Yvonne's out. Kevin is out. Daniel is out. Everybody else is here. Yeah, so of the answer, take the derivative. So now we're going to do d dx of e to the 2x over 2 plus c. And I should get back to here. Right? So the 1/2 goes for the ride. E to the 2x is its own derivative, but I need the derivative of the inside. That's another 2. Plus the derivative of c is 0. And you can see it right away. I get e to the 2x. Done. Every single problem we do like this can be checked by doing your derivatives. So I see you got your integral. I see you got it wrong. I write on the page, did you check? Of course the answer is no, you didn't check, because if you checked, you would have seen you made a mistake somewhere, right? So I'm not going to say to you, check it. You should, right? I'm not going to put it in the direction, show your check. But if you got it wrong and didn't show your check, I know you didn't do the check. Right? If you got it right, I can't tell if you did the check or not, but I'm hoping you did. Right? No, it's the same thing. They're identical.
Yeah.
Yep, identical.
I was asking, is there a reason you do this? Does it help to see something, or like you did it earlier?
No, same thing. I think the prime is quicker, but you can see I'm leaning more toward this piece with a dx because of my two-piece operator for the integral, right? Two-piece operator for the integral, right? First piece is my integration symbol, and the second piece is with what variable are you integrating with respect to, right? So the integral with respect to x, or the integral with respect to u, or et cetera, right? Let's do another one like that, another example. At this point, what is my method of choice? That I want to be able to see a function and its derivative. Well, I see a sine function, but I don't see a cosine function, right? So I have to manipulate it. If this is the level I'm at, if I'm saying to you, do this integral using a substitute for f and a substitute for f prime, right? You know I have to be looking for a sine and a cosine, or a cosine and a sine. So my pre-cal students know I love to throw these identities on here. This is 2 sine x cos x. And I guess one of my earlier methods would have been, I can take a constant out, right? I can remove the constant from the integral y. Why is it very obvious I can take this constant out? What is the integral? It's a letter S, right? What is my letter S standing for? A sum. Yeah, so it's just a coefficient. I can multiply by 2 later, right? It's just a sum. Take the factor of 2 out of the sum, right? It's also a limit, right? This integral is a limit, yes? Can constants move in and out of a limit? Hell yeah. Constants can move in and out of a limit. Why? Because they're sums, right? So it's just a factor. So what if we let u be sine of x here? What's du? Is that true? is the derivative of sine cosine. Yes, right? So I get the integral, 2 times the integral of u du, which of course becomes 2 u squared over 2 plus c, but u is sine, right? So 2 sine, oh, sorry, just sine squared of x plus c, right? The 2's cancel, yes? So we got a pretty important note here, is that constants can move in or out, coefficients can move in or out of integrals, right? Anything strike you as interesting in this problem I just did? Yes. Sure, Grace. Very good. Very good. That's exactly what I'm looking for. What if I switched my u and my du? Okay? I think that's what you're asking me, Grace. But let me do that, and then we'll come back to your question, okay? So here I am again, 2 times the integral of sine x cos x dx. And what if I let u be cos of x? What's du? Negative sine of x. But I don't have a negative sine of x. So I'm going to make it happen, right? So I'm going to put a negative on the outside and a negative on the inside. What happens to those 2 negatives? They cancel. And by the way, I've just multiplied by 1, right? You agree with that? Negative 1 times negative 1 is 1. So this is part of that earlier trick. I can multiply by 1 anytime I want. So now, what's my substitution become? The cos of x is now u. What's negative sine x dx? du. So I have negative 2 times u squared over 2 plus c. But my u is cosine, so I get negative cos squared of x plus c. Wait a minute, look at those 2 answers. Look at those 2 answers. I've got a sine squared x plus c and a negative cos squared x plus c. How am I asking you to check these? Derivatives, right? So if you took the derivative of both of those, guess what? You'd get back to sine 2x. Let's do that. Let's do sine squared x plus c. That derivative, what do I get? 2 sine x cos x, which of course is sine 2x. Nice, right? And the other one is c minus cos squared x. Derivative of that is 0 minus 2 cos of x times another negative sine of x. What do you know? I get 2 sine x cos x, and that's still sine 2x. Same. Both answers are correct. Both answers will give you the same areas. Ian?
So if we let u equals x, when we get to the negative number,
So in the second problem? Yeah. So what I'm really doing when I say u is a function, instead of me just grabbing everything else, what am I actually doing to u? What am I actually doing to u? is I'm doing the derivative to both sides. Right? You see it now? What's the derivative of cos? Yeah, minus sine, right? And do you see, that's a dx. Do you see where my dx goes to the other side? So I'm actually not really just taking it, I'm actually doing the derivative there. Did that answer you, Ian, there? Yeah. Grace, did I answer yours too? Thank you. All right, one more today? Maybe with two more levels. Yeah. I started from here. And then the bottom two, the last three lines is me checking. All right, we ready? What level was I at there? 5? Yeah. So my first level of u subs is take a u as a whole function, right? Find the derivative of that and make the du happen. Yes? Here's our level 6. U sub, oh, sorry, number 6. U sub level 2. I'm just making these names up as I go. Just so you know, I think it has 4 or 5 versions of U subs. Okay? So the first one is look for a whole function. The second one is let U be the inside. Let U be the inside. So you can see I'm really playing with chain rule here, right? Let U be the inside is my next level. Let U be a whole function. Let U be the inside. Let U be the denominator. That's coming next. What's the last one? I don't remember. Okay. So if I let U be the inside, right? Oops. So I'm doing the integral of f of x dx. U is now going to be x, which gives me what? Take the derivative of both sides for me. What do you get? U prime equals 1, or better yet, du equals dx. So now I have the integral of f of u du. I like this function f of u because it sounds like I'm cursing a little bit, right? F of u. In Italian, maybe. I'm getting in trouble for that. So this will make more sense as I do a couple of examples, but let me start with one I already know. The integral of e to the 2x dx. Well, if I take the whole function here, I get e to the 2x, right? And do I see another e to the 2x? No, so I can't take the whole function, right? Because I'd have to also see the derivative. But I do clearly see an inside, so what is u? 2x, right? What is du? 2 dx. I notice I'm keeping they're called differentials. Du and dx are called differentials, okay? So I'm keeping my differentials isolated. I want the differential of u, the thing that says we took a derivative with respect to u, and the dx to be on separate sides. I have the dx, but I'm missing the 2, correct? So I'm going to take the 2, I'm going to cancel the 2 that I'm going to put on the inside by multiplying by 1. So 1/2 of 2e to the 2x dx. There's lots of ways I can do this. I personally like multiplying by 1. So I multiplied by 2 over 2, right? And the 2 that was in the numerator I put into the function, into the integral. There's another way to do that, which I'll do in a second, all right? But this is my personal choice of how I like to do these integrals. Now I can make my u sub, right? So what do I have? 1/2 of the integral of e to the u du. Make sure you agree with that. That 2 dx is du, right? And e to the 2x is e to the u. I'm back at one I recognize. If I get a slope of e to the u, what was the original function? E to the u. E to the u, not e to the 2. E to the u, what did I write? U to the 2. E to the u, right? Derivative of e to the u is e to the u, right? So, but what is u? It's 2, so I get 1/2 e to the 2x plus c. And there's my answer. And of course, I'll double check by doing a derivative. Substitute with the whole function is level 1. Substitute inside is level 2. Substitute downstairs is level 3. How are we doing here? Question?
I'm not sure how to do it now, but
Well, say again, where did I get the 1/2?
yeah.
Yeah, I'm multiplying by 1, notice that. And how did I know I needed a 2 inside? Once I took this derivative, I noticed I got a 2 dx. But I don't have a 2 dx, I just have a dx. So I can multiply by 2, but I have to also divide by 2 to cancel it. Now, let me show you the other way to solve this. So some students don't like this multiply by 2 and divide by 2. I don't know why, but some students like it, a different version of it. So here we go. Same idea. Sine 2x dx. It's clear I have an inside, right? So let u be the inside. What do I get? U is 2x. What's du? 2 dx. So I now have sine of u. And if you notice here, if I solve this for dx, I get dx equals du over 2. So there it is, du over 2. And that 1/2 can come out. We know the antiderivative of sine is what? Negative cos, right? So negative 1/2 cos of u plus c, but I know u is 2x, right? So I like the trick of multiplying by 1. Some students in my some 20 years of teaching this don't like that. They like to solve for dx or solve for what you have and then make the substitution. Let's do maybe a couple of more and then quit for the day. We got the tough ones coming up. This is not tough right now, it's just brand new to you, right? So like the first time you drive somewhere, it's a little confusing, seems to take forever. Second time you drive there, it was like no time at all. You got there, it was fine, right? So you're just gonna have to practice and you'll get used to things. The trick right now is deciding what is going to be you and then taking the derivative of that and making that match up, right? It's a nice little game, right? I want to go to my next level, but I'm so bored. Let me go to the next level a different way. I was going to say, okay, now substitute downstairs, okay? But let me do that a little differently. By calling this next level. It's still a U sub. But I call it change of variable. So what's going to happen is I'm going to still do things the same way up until this point. But I'm going to make my substitution, and notice I'll have leftover x's, right? So we have to, in this one, we have to find a way to replace leftover x terms. Well, my process is, do I recognize it? No. Is it a power rule? No. Can I divide and conquer or long divide? It's not even a fraction, right? Can I see a whole function and its derivative? Well, if I took x as my function, I get a derivative of 1. That's no good. I got square root left over. If I took the square root as the function, I have 1 over 2 square roots. I don't have another square root there. It's not going to work. Is there a clear inside? Is there an inside? Yeah. What? So that's my U. That's my choice for U. So what's du? Nice. I have a dx. I have an inside, right? But I have a leftover x, right? Do you see my substitution at this point? I'm a little confused because I have x square root of u du. I can't integrate that x with respect to u, not until Calc 3, by the way, for the engineers. So I have to replace this x with something, and I usually will find it here. Right? Notice that x is u plus 1. So this is change of variable. I'm changing all my variables into u. Right? So now I get the integral of u plus 1, u to the 1/2 du. So U sub so far, replace a whole function, replace an inside, replace and clean up the other variables, right? It's usually going to happen when I pick U to be the inside and there's leftover pieces. So I'm going to distribute here, and I got a power rules, right? What do I get? The integral of U to the 3/2 du plus the integral of U to the 1/2 du, right? Agreed? Everyone agree with me there? So I get U to the 3/2 plus 1 over 3/2 plus 1 plus U to the 1/2 plus 1 power over 1/2 plus 1 plus a constant C. I get U to the 5/2 over 5/2 plus U to the 3/2 over 3/2. So I get 2/5 U to the 3/2 times U to the 2/2 plus U to the 3/2 times 2/3. And you can kind of see where I'm going here. What do I get out of the upstairs? I get a 2U to the 3/2, and out of downstairs I get a 15. So I got a 3U plus 5.
That's 20.
What's that?
20. Both for the multiple. It's 20.
This one, right?
No, the one below it.
Oh, one below it?
Yeah, it's time. The power of the second one.
Yeah, 3/2 and 2/2, right? Right, because 3/2 plus 2/2 is 5/2, yeah? I forget what U is. X minus 1?
Yeah.
Yep. So I have 2 times x minus 1 to the 3/2 over 15 times 3 times x minus 1 plus 5, all plus c. Yep. Yep. Let me give numbers. Where are you?
Now I'm all the way above.
Okay, nice. So final answer, 2 times x minus 1 to the 3/2 times 3x plus 2 all over 15 plus c. There it is. Yuck. It's just easy if I replace it back here before I factor, it's a mess. It's just a mess. You can do it anywhere you want. How do I know this is the final answer? Completely factored single fraction plus a constant of integration. Yeah. Yes. Yes. Even before that? Yep. Yep, I'm distributing my u to the 1/2, right? So u times u to the 1/2 is u to the 2/2 times u to the 1/2. is u to the 2 halves plus 1 half is u to the 3 halves. Yep. Yep. It's just new, okay? It's just new. That's all. It's not difficult. You can do it, right? What's the main thing? Decide on your version of u. Take the derivative and then force the substitution, right? Force everything, all the x's to disappear. And that's where you just have to practice and you'll get used to it. And you'll get stuck and you'll ask for help, right? Next week I'll give you a real nice version of every integration method we're going to do. Right, I made a packet out a couple of, I think, spring 2020. So I'll give that to you. I would say, what are you practicing anything this weekend? Go over your quiz, make sure you're fixing your mistakes and you know what's right or wrong. Redo the problems I've done in notes. Check them with the calculator, check them with the limit, right? You certainly can start looking at problems in 5.5, okay? So you can look at integration problems in 5.5. You can look at old tests for 5.5. You almost got everything. I think I was only, what am I on, 7? I got 5 more methods to teach you on integration. And then we're done. That's it. So you certainly can look at the chapter 5 tests and the finals and start working on them. Have a great day. Have a great, oh, is it Tuesday? I'll see you Thursday. I was going to say have a good weekend. I have quizzes if you want your quiz back.